Hello everyone, welcome to Hudson Engineering Academy. It's me, your tutor Hudson, and we're still going to continue on our lecture series on this particular topic, principal stresses and strains. So in our introduction, we did different formulas that we can use in solving particular problems. So today we're going to handle the first and the second problems that we are going to do under this particular problem. Now allow me do the first problem that we have right here. The question says a rectangular bar of cross-sectional area. Remember, area is given, so let's take note of what is given. Area is 10,000 millimeter square. Then we know it is subjected to axial load, so load P is 20 kilonewton. 200 kilonewton. I mean 200 kilonewton is the same as 200 kilonewton times 1000 in terms of what? Newton, like this. Yes. Then it is you're supposed to determine the normal stress and shear stress on the section inclined at 36 degree to axis of stress. This is very important. Now, first of all, given area and the load, we can calculate the what? The stress. You know, stress is given by the formula load out of area. So that means this one is going to give me 200 times 1000. Then I divide this by 10,000, which is the area. So you realize that this and this will cancel. Then this and this will also cancel. So we shall remain with 20, which is now what? Newton in millimeter square. So this is now our stress. That is sigma x, that we're calling sigma x as we did in the previous video. Now, given this particular information, allow me just draw it here so that we can easily get it. Remember, in this video, I'll show you how simple you can calculate this easily, because what are the terms given? The terms here, most importantly, is that we have the load, and this load which has been given is the axial load. So it is, in terms of stress, it is producing a stress which is 20 Newton per millimeter square. Okay, so that means the value of sigma x here is given. The same on this side. It is what? Sigma what? X. Now, the section has been inclined at 36 degrees to the axis of stress. I think. So this is our axis of stress. Now, let's have the plane being inclined like this. So it is said that it is inclined to the axis. I think. This is the axis. So it is inclined at 36 degrees. Okay. So remember, in our first introduction that we did, we said that when you're doing the calculation, the theta that you consider, the angle, the oblique angle that you consider is the angle which is what? With reference to the vertical one. So that means this is what? This is the angle that we need, which is what? Theta. But the angle given is not the oblique angle which we want. So that means given 36 here, and just getting this triangle, this is 90. So what should be this what? This theta. This theta is going to be, because the summation of angles inside this triangle should be 180. If this is already 90, so this plus this would also be 90. So that means this 90 minus 36 will give you the angle that you want, which is 54. Okay, 54 degrees. So that is the value of theta that we need. So you have to check carefully which angle has been inclined to what. Okay, if it's inclined to this the axis of stress, that means it is this one. If it's inclined to minor axis, that means it is what? This one. So you need to, in my next video, please don't miss that video. I'm going to explain to you a situation when it's inclined to the what? To the minor one, so that you see how you get this what? This particular angle of theta. Now, given this information, we can easily calculate the first one, which is what? Sigma normal. Sigma normal, last time we found that the expression is sigma x cos square theta. Okay, so when you substitute this, what is going to be your answer? Sigma is 20, and then cos square of theta is now what? 54. Okay, 54 degrees. So what will you get as this answer? You just check from your calculator. According to my calculator, I think I'm getting something like 6.91 in terms of Newton per millimeter square. So you get to calculate that. Okay. Then the second case, we're supposed to find the shear stress. In this case, that is the same as tangential stress. This is sigma t, and sigma t is equals to, we found that the expression is sigma x by 2 sine of 2 theta. Sine of 2 theta. So mind you, this one is square, but this one is 2 theta. Okay, so you need to take note of that because it's very important and very vital. Now sigma t is going to be equals to, what's the value of this? This is 20 divided by 2, and sine of 2 times what? 2 times 54. Okay, so you just have to press this using your calculator and you'll get the value easily. Okay, the tangential sigma t, I mean. So what do you get in this case? You're supposed to get around 9.51. Okay, 9.51 Newton per millimeter square. So this is our first question that we were supposed to find this and this. Nothing else. So I will take you to the second problem. Well, in our second problem for today, the question has been given that the tensile and the compressive stresses at a point across a mutually perpendicular planes are 100 and 40. Okay, then that means what is given is, we have sigma x already given in terms of 100 Newton per millimeter square. Okay, as you can see, and sigma y is also given to be 40 Newton per millimeter square. Now they said the first one is tensile, so that means it is positive. Okay, then the second one is compressive, that means it is negative. So you need to take note of that. Then you're supposed to calculate the normal, tangential, and the resultant stresses at 20 degrees to the axis of the minor stress. This is what I was saying, that we're going to do one problem which the angle has been inclined to the minor stress. So to make it easy, let's have a sketch so that you can easily understand the inclination. Okay, yes. So our major one, sigma x, has been given. So we can indicate this, that this is sigma x and this is 100. Okay, then it is away. If it's away, that means it is tensile. Okay, positive. Then what about sigma y? It is compressive. Okay, so we indicate that this one is sigma y and the value has been given to be what? 40. So when it is compressing the member, it is what? Negative. Okay, so if this is the axis, the minor one, and this is the major one, and they say the plane has been inclined. Okay, so let's have the inclination here. This is the inclination, so I can have that. It has been inclined 20 degrees, so this angle is 20 degrees to the axis of minor stress. This is what it's meant by that. Okay, so if this is 20 degree, this one from the axis of minor axis stress, I mean, that means this alternate to this is also what? 20. Okay, well, you can clearly see that that is the angle which is what? Oblique. It's oblique angle to the vertical that we were saying. So that therefore means our theta is that very 20. I hope you have understood. I have extracted from this to be alternate angle to this. They have not given this one to the what? Major stress. This one, major axis. No, to the minor one is the one which is given. So our theta is given to be what? 20 degrees. Now the first question says we find the normal stress. So sigma normal, for this particular case, this was our second case where we have two perpendicular and mutually, okay, stresses that we have. So the formula that we got was sigma x plus sigma y by 2 plus sigma x minus sigma y by 2, and this is cos of what? Cos of 2 theta. This was our formula. We got to substitute this. Sigma n is going to be equals to, what is our sigma x? It is 100 plus, what is our sigma y? Sigma y is minus 40. Don't forget with that sign because it is compressive. Then everything is out of what? 2. Okay. then plus, this is positive 100 minus sigma y is minus 40. Okay, everything is out of 2, and this is cos of 2 times theta is 20. Okay, so you just have to enter this in your calculator and you get the value of sigma what? Sigma n. And according to my calculator, I have 82.6. 82.6 in Newton per millimeter square. Okay, so this is how we calculate for sigma n. Let me show you how to calculate for sigma t. That is the tangential one that the question is asking. Remember, this word tangential is the same as the shear stress. If they ask you to calculate the shear stress, just like in our first question, it's the same as they've asked you to calculate the tangential one. So we get this, and what was the expression? The formula we found was sigma x minus sigma y by 2, okay, sine of 2 theta. So this is what we had. So we got to substitute this. Sigma t is going to be equals to sigma x is 100, okay, then minus sigma y is minus 40. Minus 40. Everything is out of 2, and this is sine of 2 times 20. Okay, so sigma t is going to be equals to 44.995 Newton per millimeter square. Okay, yes, so we have found the two values. Now what we are left with is the last part of the question, which is asking for the resultant. Okay, so I'll just erase this part and we use it to find the resultant. So sigma resultant is going to be root of sigma n square plus sigma t square. This expression I didn't give you in the first introduction, so take note. When you ask to find the resultant, you take this formula. It's you must first have sigma n and sigma t, then you substitute it here. Okay, so sigma resultant is therefore going to be root of, what do we have here, 82.6 square plus 44.995 square. The answer is 94.06 in Newton per millimeter square. This is the final answer. So we have come to the end of this video. Thank you so much for watching this video till the end. Please do like the video, share with your friends, subscribe to this channel so that you don't miss any of my videos.